क्या आप स्क्रीन को देख पा रहे हैं?
Yes, sir, completely.
Yes,
क्या
sir.
Yes, sir.
क्या लिखा हुआ है?
Yes, sir.
Internal energy
Internal
or
energy.
thermodynamic process.
Thank you. Okay, then, dear students, yesterday we have studied about the internal energy. Internal energy is the sum of the various types of energy possible for a system. So all kind of energy, when we make the sum of all these energies, we get the internal energy. Internal energy generally depends upon the temperature. So when temperature changes, internal energy changes. Now we should understand about the internal energy. So let us try to understand the internal energy in the scientific manner by performing some experiment. In this experiment, we generally choose one system and we change its state. So my dear students, the process by which we change the state of the system may be of various types. It may be isothermal, where temperature remains constant, isobaric, where pressure remains constant, isochoric, where volume remains constant, and adiabatic, where the heat content of the system remains constant. Now, in what condition we can change the internal energy? So, internal energy can be changed by either giving the heat to the system or by removing the heat to the system. Second thing we can do is by doing some work on the system or by doing some work by the system and by adding the matter to the system or by removing the matter from the system. So these are the 6 ways by which we can change the internal energy. Now to change the internal energy, let us do one process. The type of process we want to do is an adiabatic process. Adiabatic process is process in which we do not provide heat to the system, but still we can change the temperature. So the heat content of the system remains constant. For doing it, we need to do some work because we are not going to provide any heat to the system. So we'll have to perform some work. The first type of work that we are going to do is the first way of work. In the first manner, we generally we take water inside the adiabatic container, and in this adiabatic container, my dear student, we put an arrangement of moving paddles. So we paddle so that this fan moves, and thus the internal energy of the system changes. If the internal energy of the system initially is UA and the final internal energy is UB, and if UB is greater than UA, then we can write that delta U is equal to UB minus UA. Here initial temperature was T1, but by paddling we have changed the temperature to TB. And this is why change in temperature is also delta T, that is TB minus T1. Same way in the second way, my dear students, we do some electrical work. So the immersion rod is put into the water. We have a facility of stirrer so that we can move this water. So water can be heated equally in all the water can be heated equally. And then we change the temperature of water from TA to TB. So once again here we have the temperature difference is your TB minus TA, and the change in the internal energy is UB minus UA. Thus the change in internal energy in both the cases, in case 1 and case 2, are equal, and that is why the total change in internal energy we can say is the work done by adiabatic process or work done adiabatically when you have the container which is adiabatic or the container which does not allow the heat to pass through or it maintains the total heat content of the system. Now, my dear students, we want to understand the work done sign convention. In what condition we can say that work done is positive or work done is negative? Let us understand. The positive sign express work adiabatic is positive, and when the work is positive, when work is done on the system, the work done is positive. Similarly, if the work is done by the system, if the work is done by the system, WAD will be negative. So this is how, my dear students, you can see that we have done something from outside. So there is a change in the system, and that is why the work done on the system. Uh, Other state functions, uh, my dear students, then we have proved that in both the cases where we have done work by two different ways, we found that the total change in internal energy is same. The total change in internal energy is same, and that is why the total uh, temperature also remains, change in temperature also remains same, and that is why we can say that the change in internal energy delta U or internal energy U is a state function, and that is what we have proved by this experiment. So it's a state function, and it depends upon the initial and the final state of the system, but it does not depend how the work is done, whether we have done the electrical work or we have done the mechanical work. The change in internal energy, if the change in temperature is same, the change in internal energy will also remains the same. Now, my dear students, let us study the other state functions. So the other state functions are volume, pressure, and temperature. Let us understand how the other state functions are same. Temperature state function. Temperature as a state function, let us study. Now, we have two main points. One first point is your T1, and you have the another second temperature you need to reach is T2. Now what happens, you can move from T1 to T2, which is known as the path 1, and you see slowly hit the system which was at 25 degrees centigrade, and you turn it out to with 35 degrees centigrade temperature. You slowly heat it from outside, and then you get to go from T1 to T2. But now suppose you choose the another pathway at T1 at 25 degrees centigrade, you cool the system. So the temperature of the system goes lower and it becomes 10 degrees centigrade. Then you heat it slowly, gently, and let it go to the temperature T4, which is 17 degrees centigrade. And from 17 degrees centigrade, you start heating it and provide it intense heat. And then the temperature suddenly rises and it goes, you can see the slope is even steep. So with the steep slope, it goes from T4 to T2, that is 17 degrees centigrade to 35 degrees centigrade. So here you can see that T2 is greater than T1, T1 is greater than T3, T1 is greater than T4, T4 is greater than T3, and T2 is greater than all of this T1, T4, T3, and all of them. T2 is the highest temperature. Now, my dear students, you have two different paths. One is path 1, another is path 2. So path 1, you directly go from 25 to 35. In path 2, you go from 25 degrees centigrade to 35 degrees centigrade by cooling it first, then slowly heating, and then heating strongly. If we bring a change in temperature of the system from 25 degrees centigrade to 35 degrees centigrade, T1 to T2, the change in the temperature is plus 10 degrees centigrade. We may go straight from T1 to T2 by the constant heating, that we choose the path 1, or we cool the system from T1 to T3, that is 10 degrees centigrade. T3 to T4, we go by heating slowly up to 17 degrees centigrade. So T3 to T4 by heating slowly, and from T4 to T2, that is up to 35 degrees centigrade, the final temperature is the 35 degrees centigrade by strong heating. This is your path 2. But initial and final temperature, that is T1 and T2, are same for both the system. Thus T is a state function and total change in temperature is plus 10 degrees centigrade. So final temperature change you will find is plus 10 degrees centigrade, whether you choose path 1 or path 2. So change in temperature, that is your delta T, is independent of the route taken, and that is why we can say that the temperature is a state function. Volume of water in a pond is a state function. Now how? Let us try to understand. Suppose we have a pond. In this pond, we want to fill the water. Now, we can fill the water by the various ways. Let us see what are the various ways we choose. Change in volume of its water is independent of the route by which water is filled in the pond, either by rain, so you can fill the water by raining, or by tube well. You can use a tube well and fill this water inside the pond. But ultimately, the total volume of pond will be filled, and this is how the volume itself is also a state function. Now, my dear students, this is how we can understand about the state functions very easily and very nicely. Now, let's move and understand something more about it. But if you could not understand anything in between, you can ask me. Do you have any questions to ask, my dear students? बच्चों, क्या आपको कुछ पूछना है तो आप पूछ सकते हैं.
No, sir.
सब समझ में आ गया है?
सर स्क्रीन नहीं दिख रही.
हाँ बेटा, पहले मैं जो पूछ रहा हूँ उसका आंसर दे दीजिए, इतनी कृपा कीजिए.
यस सर.
यस सर.
चलिए, अच्छी बात है. अगर आपको सब समझ में आ गया है, then let's move to the next part. We have studied about work. Now we are going to study about heat. You might aware that we have started studying about the work. Now we want to study about heat, my dear students. So let's study about heat. Here we have. We can also change the internal energy of the system by transfer of heat. You know, we can change the internal energy of the system three ways. One is by doing work. Another one is by changing the heat content of the system. And third one is by changing the matter. So now we are going to study, or we are going to change the internal energy of the system by changing the heat. We can also change the internal energy of the system by transfer of heat from the surrounding to the system, or from the system to the surrounding, without expenditure of work. Remember, we can do it without doing any work. We can change the heat content without doing any work, my dear students. Please remember this. This exchange of energy, which is a result of temperature difference, is called heat Q. So when you change the energy of the system without doing some work, and with the change in the temperature. So when the temperature changes, my dear students, the heat content of the system changes if you do not allow the work to be done. So now exchange of energy from surrounding to the system, or from the system to the surrounding. We can exchange the energy by two different ways. We can exchange the energy from surrounding to the system. We can exchange the energy from system to the surrounding. That results in the temperature difference in the system. And energy is exchanged without expenditure of work is called heat. So what is heat? So when the energy change takes place in the system, and if the energy change in the system is done on without expenditure of work, is known as heat. We use isochoric walls. So what is isochoric wall, my dear students?
Have you prepared any heat content for our
We use the isochoric walls. To exchange the heat, we require thermally conducting walls, but volume is not allowed to change. We use the isochoric walls. My dear students, can you tell me the meaning of the isochoric walls?
YouTube channel name, sir?
We use isochoric walls. What is isochoric wall? Can you hear me, my dear students?
Yes, sir.
Tell me, what is isochoric wall? See, isothermal means temperature constant. Isothermal means temperature constant. Isobaric means pressure constant. Isochoric means volume constant. And isoadiabatic means heat content constant. So we use isochoric walls to exchange. Isochoric walls means we do not allow the volume of the system to be changed. So this is how, my dear students, we understand about the isochoric walls. To exchange heat, we require thermally conducting walls, but volume is not allowed to change. Please remember that to exchange the heat, remember, when we want to exchange the heat, we require thermally conducting walls and the volume should not be changed. So if the volume is not being changed, we can say that we have added or removed the heat. If volume changes, that means work is done. And in that cases, we do not exchange the energy by expenditure of work. And that is why we can say that we have not provided or removed the heat. So when you increase the energy by keeping the volume constant, it is known as the heat. Please remember, it is an important concept, my dear students. We take water at a temperature TA in a container having thermally conducting walls, say made up of copper, and enclose it in a huge heat reservoir in a temperature TB. So what do we do in a huge we take, to understand this, the heat exchange, we take a water at temperature TA. So at TA we take at TA temperature we take water in a container. This container is having the thermally conducting walls. When we have these thermally conducting walls, they are made up of either copper or any other conducting material, which is enclosed in a huge heat reservoirs, and the temperature is TB. Now temperature TB is greater than TA. Water at temperature TA will absorb heat from the reservoir, that is the heat reservoir whose temperature is maintained TB. Now you can understand the same with this figure, my dear students, so that you will get a better idea. Please pay attention to this figure. See, you can see that we have a water at temperature TA. This water is placed into the vessel that is made up of copper vessel, which is a conducting material. This water is kept into the another water reservoir. The temperature of this water reservoir is maintained TB by providing some energy to it. Now what happens? Remember that this water reservoir's temperature is neither anything less than TB or not more than TB. We provide electrical energy just to maintain the temperature. And then we put this water which is at temperature TA into the vessel here inside. So you can easily understand that we have this vessel TA, we have this vessel whose temperature is TA, we have the another vessel whose temperature is TB, and finally we have this kept for some time. You can see that I have written here that reservoir in which TB temperature maintained water with the temperature TA is enclosed in it. So when you have this reservoir, it has the temperature maintained up to maintained at TB without any and then we put the water that is having the temperature TA inside it. Due to absorption of heat, please remember, due to absorption of heat, the temperature of both the water is finally become equal to TB. Now this is very important thing, my dear students, we need to understand. Suppose you have a system A and then you have system B. Suppose you have the another system B. This is your system B. And then you keep the another system, that is the system C. Now remember that if you maintain the temperature of the system B 50 degrees centigrade by heating it some other way. And if the temperature of this system is, let's say, 20 degrees centigrade, and the temperature of this system is 40 degrees centigrade. And if you keep maintaining this system at 50 degrees centigrade for a longer time, and if all the systems are in contact with each other, they are not insulated, they are in contact with each other and the walls are conducting walls. After some hours, you will come to know that all this ABC will have their temperature 50 degrees centigrade. One more example I can give you, my dear students, that if you have a, a bucket made up of copper, you keep it in your bathroom for taking bath. The temperature of that water inside the bucket is 50 degrees centigrade. It's a cold winter day. You will come to know that after 2 hours, when you go for a bath, the temperature of that particular water has decreased and it has become the temperature equal to the temperature of your water present in your tank, because ultimately the water has to be decreased. Same way, my dear students, if you take the ice in the bucket and keep it in your room, and after some hours, some 2, 3, 5 hours, if you watch this water, you will come to know that the ice has melted and the temperature of that water has increased, and it has been increased to a level where the water becomes equal to the room temperature. So when two or more systems are in contact with each other, my dear students, they exchange their heat if the wall is conducting, and then the temperature of all this system or all the three systems become equal. The same thing here, the same thing happens here, that the temperature of water, which was initially TA, turns out to be TB. Thus, some heat is absorbed by the system. Now you can understand that the system has absorbed some heat. So the vessel which was having the temperature TA for water, that water has absorbed some temperature, has absorbed some heat, and the temperature turns out to be TB. This is what it happens. So heat Q can be measured in terms of temperature difference. So you can see that whenever there is heat absorbed or heat released, it takes place without the change in the volume, and that is how the temperature difference simply represents, and that is what it causes the difference in the temperature of the system, and that is why heat can be measured in the form of the change in the temperature. So if the temperature is increased, heat is absorbed. If the temperature decreases, heat is released. If temperature is increased by 1 degree, heat is absorbed to a certain extent. But if temperature is increased by 5 degree, more amount of heat can be absorbed. Change in temperature, that is delta T, is equal to TB minus TA. Change in internal energy, delta U is equal to Q. Your change in internal energy is delta U is equal to Q, that is plus or minus. So the value of Q can be plus, the value of Q can be minus, my dear students. And thus the change in temperature, delta T is TB minus TA, whereas change in internal energy, delta Q is equal to plus or minus Q. Change in internal energy is equal to the heat change or heat exchange. So now when we do not have a change in volume, the change in internal energy depends upon the change of heat change. Now we'll study about the sign convention. Heat Q is positive when heat is transferred from surrounding to the system. When heat is transformed from surrounding to the system, that means if the temperature of the system increases, then we can say that heat is absorbed and the value of heat is positive. When temperature decreases, that means the heat is negative when heat is transformed from the system to the surrounding. So if the heat is transformed from the system to the surrounding, the temperature of system will decrease. And thus if the temperature of the system decreases, we can say that the value of Q is negative for system. Now as the heat goes to the surrounding, that value of T, the value of Q will be positive for surrounding. But for system, we should say it is negative. So this is how, my dear students, we understand the exchange of heat and the sign convention. Now, my dear students, we want to study the general case. What is the general case? Let me explain and then I can read the text for you. General case is the case where we do the change into the internal energy by doing both the things. That means by doing work and at the same time by exchanging the heat. So when we exchange the heat as well as we do the work, we can say that it is the general case. So in general case, we bring about the change in internal energy by both, that is by doing work and by transfer of heat. So when we do the work by transfer of heat as well as by doing some work, let us study what happens and how do we calculate the internal energy of the system. So in general case, change in internal energy delta Q is equal to, the change in internal energy delta U is equal to Q plus W. What is the meaning of Q, my dear students? That here the Q represents the heat exchange and here W represents the work done. So now in this case, or now when we think about the general case, my dear students, we come to know that the change in internal energy is brought about by doing some work, at the same time by exchanging some heat. When we do some work and when we exchange the heat, the change in internal energy depends upon both the change in by the change in internal energy depends upon the work done. As at the same time, the change in internal energy depends upon the change into the heat. That means either heat is absorbed or heat is released. Equation delta U is equal to Q plus W that we write because sometime or when both the work is done and when the heat is exchanged, the total change in energy is the sum of the heat exchange plus work done, and that is why we write Q plus W. Equation Q plus W we can write. So equation delta U is equal to Q plus W is called the mathematical statement, or it is the mathematical statement of the first law of thermodynamics. So equation delta U is equal to Q plus W is called the mathematical statement of the first law of thermodynamics, and is also called the law of conservation of energy. Please remember that it is also called the law of conservation of energy. Now, my dear students, we may have few more law of conservation of energy. Number one, the energy of an isolated system is constant. The energy of an isolated system is constant. Energy can neither be created nor be destroyed is also the statement of the law of conservation of energy. So please note, my dear students, that there is a considerable difference between the character of thermodynamic property and the mechanical property such as volume. So please, my dear students, please make sure that you have understood that we have studied about the law of conservation of energy, which says that in a chemical reaction, energy can neither be created nor be destroyed. But my dear students, the one form of energy can be converted to the another form of energy, and the another statement says that the energy of an isolated system is always constant, or we can say that energy can neither be created nor destroyed. So this is how, my dear students, we uh, study about the first law of thermodynamics, and the equation delta U is equal to Q plus W is known as the mathematical equation for the first law of thermodynamics. Now here we have seen the note that there is a considerable difference between the character of thermodynamic property like energy and the mechanical property like volume. Let us see how is it, what does it mean. We can specify unambiguously, that means absolute value for volume. That means we can say that the volume is 2 liter, the volume is 5 liter. But at the same time, uh, value, that is a mechanical property of a system in a particular state, but we cannot specify unambiguously or absolute value of internal energy. Please remember, my dear students, that the internal energy of the system, we cannot say that U is equal to 2 kilojoule. No, we cannot say U is equal to 2 kilojoule. We can say that delta U is equal to 2 kilojoule per mole. So what they want to tell us is that we cannot write the value of internal energy in an absolute manner, but we should write the value of a change into the internal energy. We can measure only the change in the internal energy of the system, but we cannot make the absolute, or we cannot write the absolute value for the internal energy, my dear students. This is how we truly understand about the internal energy. Now, my dear students, we should stop the class little early today, because because of the assembly, the class has been shortened to certain limits. So we should study about this problem into the next period. Uh, if you have any doubt, you can ask me, or you can move to the next class. Wish you happy learning.